Hey guys, so in this video I'm going to be talking about using chops to generate some interesting motion for particles. And so you can see in this example I'm doing a couple things. I'm doing like this non-uniform sequential activation. A little bit tough to see, but like if one particle starts, it'll sustain, and then the next others will go like on, and then on, you know, like that. So we're getting that behavior from chops, and then we're getting sort of like the size, like the spread of the emitter, the speed, and then the life on the particles are being driven by that. So let's start from the top and go through that. And just a disclaimer, I'm pretty new to chops. I might be making some mistakes. I learned about this sort of like today or maybe the last couple weeks. And chops, it's been very great because it's very visual, and so you can see how your noise curves work. So we get the points. I put an ID attribute on them. It's not really necessary. And actually it would mess up the particle sim down the line. Let's do this. Let's just fix that right now. ID. Don't set ID. Because the particles inherit the ID. So we get our points, our sphere right here. And let's go into how we activate the particles. So I get a noise curve. I'm going to open up the motion effects view. And I'm going to just, you know, get my noise, get it into a space that I like. I normalize it with a limit, and then this normalize checked. Then I stuff it between 0 and 1. Very handy. And then what I do, this is very important because what we're going to do is we're going to integrate with the area chop. And as you can see, we get this curve that's climbing up like that. Let's integrate that again, or not integrate. Let's normalize it again, bring it between -1 and 1, and then put it between 0 and 1. And then we're going to multiply by the amount of points on the sphere. So now we have for each one of these levels here, this is the levels here. We're going to use a limit, quantize, and we're going to set to floor. And we're going to set the value step of 1. So every one of these, this frame is going to correspond to this particle. And we're going to take this data, we're going to export it to this channel right here, and we're going to have a particle attribute here called activate, and it's going to be if that chop number equals, if this chop equals the point number, set activate to 1. So when we're like in frame 1, I think maybe frame 1 is right here, or no, maybe like frame 6 or something like that, we get a value of 1. And we check that to the particle. So on every one of these steps, this is the particle that's going to be activated right here. That's when it gets an active value of 1. All right. So next what we're going to do is we're going to take this. I couldn't figure out how to do this in another chop, or in the single chop, but so I break it out. Now this is the curve that's these are the curves that are doing basically the magic of you know, shooting out the particles. It's basically doing all the work. So what we do is we bring in every one of our activated attributes over time, so it's animated. And there's the attribute. And so we don't need to rename the channels. This is basically importing our geometry. And so what we do is we put a trigger chop down. And what it basically does is for every one of those activates, it's copying this curve onto each one of these. And we can use these expressions to randomize the different values of the trigger or the attack, sustain, values to get an interesting pulse. And you can build your own, like totally your own neat chop curve out of a noise if you wanted to, but trigger was easy. So you can see the next thing I do is over the course of the activations, the particles get weaker over the frame range. Now, the reason this is maybe a little bit overkill. Now, basically, I take my active particles and I overwrite them with a value of 1, and I copy this wave from it. So basically, I build this curve so it's over the frame range, normalize it so we're getting our numbers from 1 and 0, but I flip it upside down, and the decay rate controls that little curve like that. And I don't think I need this here. This was just some adjustment, but I don't need it anymore. And then what I do is I stamp the seed value on every curve, and so I have a matching, like they all peter out just a little bit differently. They don't peter out at the same rate. They're broken up a little bit. And then so as you can see with combined chops on multiply, you're multiplying the chops that have the same name. Of activate 0 gets multiplied against this activate 0 gets multiplied by this activate 0. So again, adding some noise into it. Here's the result. So we add some noise into it. I take a noise chop, and I'm going to just skip this because this is the normalize, and then this is an adjustment on the strength, on the amplitude. And I have these stamps in here to randomize the noise for every emission point. And then the same deal, multiply the chops together. And I get this data a little bit differently because you're pulling in geometry data. And what I do is I create an emission attribute, and I use the channel SOP to look at the final node in my chop network and stuff the activate channels into the attribute emission of each of the respective points. Build some normals, and then I take that emission and I'm multiplying it, by different values to give me a different life scale. So that's going to control the size of the emitter, and then that's going to control the velocity, and this will control the life. So we'll see how we do. And so as you can see, these circles sort of pulse and they go like that. So you could sort of see this. This could be used for like anime explosions or whatever. And I use the emission attribute to drive the density of particles that are scattered on. And as you can see, the circle emitter gets some UVs, and I'm just adding a little bit of noise, and then we stuff it into a pop net. I have high substeps to get it to smooth out, so this is why it's taking a little while. It's counting up. I shouldn't have done that. And there you go. And so of course you can add some more breakup. I do a couple other things. Friction and bounce are randomized. Basic collisions, and this is a basic pop. So you could do this with grains. You could do it with flip. I'm not doing that because of time constraints. I don't want to really sim anything. But as you can see, you get a relatively decent gushing behavior from this. So it could be useful. So I hope you guys found this useful, and maybe put something up and take it further. I'm pretty sure there's a lot more that can be pulled from chops, because I'm pretty new to it myself. So thanks very much for watching, and have fun.